Yeah, my name's OJ Wolanek. I'm based in San Diego. I have several years of experience with network monitoring, network management, network configuration. And today, I'm excited for you guys to join us as we take a look at how, the importance of east-west traffic visibility and how you can gain that visibility relatively easy compared to some other approaches that are out there. First of all, what is east-west traffic? I want to make sure that we're all aware and understand what that is. Essentially, east-west traffic, as opposed to north-south, is traffic that goes within the data center without transiting, sometimes another router or without transiting the internet. So this is north-south traffic. So server traffic going out to the internet. And then this is an example of east-west. And so typically people have very good visibility at the perimeter level, like where the router is, there would be a firewall typically, because that's where the security appliances are. But they might not have such great visibility within that perimeter. And so that's what we're going to be addressing today. So most organizations don't have meaningful visibility into east-west traffic. So they might have visibility, but they don't have actionable intelligence. They don't have granular enough data. They might have some data points, but nothing really deep enough to protect them or to help them understand the performance of the network. And it's shocking, only 30%, what we're seeing is only 30% of the organizations out there have meaningful visibility into east-west traffic. And this could be a problem, right? Because most traffic never leaves the data center. What we're seeing is 3/4 of the traffic that people are responsible for stays within the data center. So most people have very little visibility into most of their traffic. And that's not good. And, you could think that, protecting the perimeter should be sufficient, but 70 to 80% of successful attacks are exploiting blind spots within east-west traffic. And it's these areas that nobody's looking that are really the biggest risks for organizations. So you really need to take a broad approach to that visibility, but that kind of broad visibility could be expensive. It could be difficult, depending on how you implement your visibility solution. So there are a variety of approaches to gaining that east-west traffic visibility. One of them is network taps or spans or packet brokers. These are basically hardware appliances. There's also virtual appliances that are embedded in your network where your network traffic actually passes through these devices. And these devices will then analyze the traffic. They'll siphon it off and shoot it to other tools for analysis. But they require a high level of instrumentation. You need to place these appliances in strategic locations in your network so that you are capturing all the traffic. And that can be disruptive to business operations. It can be expensive. And so a lot of times it's not really feasible to see traffic for everywhere, right? Because of the cost and the complexity. Another option is NDR, or network detection and response solutions. These are somewhat similar to the first item, which is like packet brokers, network taps, and spans, because they do work at the full packet level. But these are really focused on, obviously, security incidents. They're not going to really help you with network operations, which is another value of east-west traffic visibility, like capacity planning and things like that. And these are also quite expensive and require a high level of instrumentation. And the instrumentation is something to consider, because the more higher level the instrumentation is, like the more instrumentation you need to implement, the less likely it is that you're going to be able to uncover all of the hidden areas of your network. The next one is endpoint telemetry or EDR, XDR for lateral visibility. So some people, obviously we talked about people have typically good perimeter security. And then we get to the endpoint, and these can provide some visibility as well. But with this, you're relying on actual end user devices and hosts to help with network security. We definitely need endpoint telemetry and endpoint security, but I wouldn't rely on. I feel like the attacks are just going to be you're too far in the network already. The attackers are too far in the network. It's too late by the time like an EDR solution picks up something, and you don't want to rely on like hosts and end user devices for that, because these host-based solutions will only work on hosts. They're not going to work on network devices. They're not going to work at the network fabric level. So you also have a high instrumentation cost, although the dollar cost is not a lot. But of course, that could change if you are breached because you're relying on just the endpoint. The final option we're going to talk about here is flow export, which is NetFlow, IPFix, SFlow, and Cloudflow logs. So what this is network metadata. So it's similar to the first two options, which are packet-based. But what flow export and flow analysis solutions do is they're looking at the metadata of the packets. Okay, and these are much lower cost solutions, and the instrumentation level is low because the technology to produce the information needed is already available in enterprise class routers, switches, and firewalls. So this technology is already there. You just need to turn it on and configure those router, switches, firewalls, public clouds to send their flow data and flow logs to a NetFlow analysis solution. And so instead of recording phone calls, for instance, right? You would just be looking at who called who. So it's much less data to sift through, which requires much less money and infrastructure. Now, there is the notion, the idea that flow solutions may not be really as suited for security and network operations because they are looking at essentially the header of the packets instead of the full packet. Okay, and that can be true, but there's a catch. So here's a packet. The blue part is where flow analysis solutions focus. They're going to be looking at the source and destination IP addresses in the packet, the ports that are used, the amount of bytes, the protocol, things like that. Okay, and then where packet-based solutions or deep packet inspection solutions work is at the entire packet. So you might think that DPI solutions like tap spans, packet brokers, NDR solutions are going to have available to them more data, right? And in a way they do, right? But in practice, what we found is that flow data solutions have a better data set, because when you're talking about data set, it's not just about the information in the packet and the amount of bytes that is at your disposal, but it's also about the speed of the insights, the contextual enrichment, the retention period, and the network coverage. And these are four elements that you get with flow-based solutions typically. So because flow solutions have so much less data to sift through and analyze, because they're just looking at the header, then they're much faster. So your speed of insights is potentially much quicker. So you're looking at seconds to run a query instead of hours or days. Okay, the contextual enrichment is a big benefit to flow-based solutions as well, because you're able to tag these flow records with whatever metadata you like, giving you additional business context. And that's something that is not exclusive to flow solutions, but it's much easier to implement because you're looking at a lot less data again. Now, with much less data, then your retention period can be much longer, right? You can store more data for longer. So you've got that look back and you've got that additional context to find patterns and anomalies and have that historical perspective. And because these solutions are fast, and because you've got the higher retention period and the lower cost to the solution, then you can afford to see everything. That's where the broad network coverage comes into play. So you can see all of your east-west traffic instead of having to strategically pick areas that you want to monitor because of cost and performance concerns. And so that's why we feel that flow data deployments are going to provide you a better data set. So let's go ahead and jump into the demo. And we're going to be talking about a variety of use cases. So we'll start with SecOps. And the first item we're going to talk about is looking at policy violations and micro-segmentation enforcement. So basically, when you're looking at east-west traffic, you want to know if boundaries are being violated, right? You have security controls in place. You need to know if those are being crossed. Micro-segmentation is an exercise in basically limiting the blast radius if there is a malicious activity within your data centers or within your network. And you need a visibility solution to understand what those segments possibly are so that you can create those segments without breaking, business operations. So let me show you an example of that. What we're looking at here is this is basically, this is a Sankey diagram showing the traffic flowing between client through an application to a service, right? And so if you're trying to perform understand if there's policy violations, you would want to see like the amount of traffic going between different zones. So in this case, I have some security zones on the left, and you can see that there's traffic going between security zones, right? Now, what I'm going to do is I'm going to ask the system to show me where there's security zone violations. So where traffic is exiting one security zone and going into another. And so with just a click there, I was able to do that. So I'm highlighting, so this Boss production security zone has traffic going to the internet, right? We've got this core network security zone with traffic going to production. This is instantly understandable from a high level perspective, and you can actually have alerts on this as well. So there can be both static and machine learning baselines or alerts that can notify you if you've got traffic going between security zones. You won't have to manually define all these zones. We're going to know what those zones are and then start showing you visualizations wherever you have those traffic crossing boundaries, right? This is going to be a big problem potentially. The micro segmentation can be performed by understanding, where your boundaries are and what you need to contain within a boundary, right? And so maybe you want to look at your applications, and so I could pick a service or an application, and I can understand how and who is using those that application, so I can understand how I can group that traffic together to keep it logically together so that it will operate. It'll continue to operate once I put those controls in place. So this is, in this example, we can see several machines that are accessing Google services, and then we can see the port that those services are operating on. Of course, we can do this for any application and not just SaaS applications, right? It could be obviously internal applications. That's where you'd want to use this mostly. And you can define your own applications as well. So it's pretty simple to do. So let's go back to the deck here. There is the idea of lateral movement detection. Okay, so you want to know when there's an anomaly for traffic within the network, right? It could be port scanning. It could be a large amount of traffic being transferred, or again, it could be security zone to security zone communication. As an example, we have several alerts going to a Slack channel. Okay, this is our system is sending alerts to a Slack channel, keeping you abreast of various incidents. So an example of lateral movement might be port scanning, right? This is a brute force attempt in this case against port 22, which is used for SSH. So I could just click on the view dashboard link, and I can see that this IP address has been involved in 243 sessions involving brute force. And I can visualize that a little bit better by looking at the flows view that we showed earlier. So this is the volume of traffic going between this attacking host on the left, and then this is my asset, my server that's being attacked. So there's been several connections or connections attempted trying to guess a password, possibly in this case, right? So I can uncover that really easily with, as an example, a Slack message. I can also very quickly understand like data exfiltration, right? I want to know when traffic is leaving my network and going to somewhere that it should not be going to. Okay, so here's an example of that. I have an alert message showing me that I've got 783K that exited my US-based network and it's going to Germany. I can click on that link. I can see that there was 2,000 packets, 764 kilobytes. If I want to get more of a visual on this, I could pivot over to GeoIP, and this is the view here. So I can see that traffic basically leaving the United States, specifically Boston, and going to Munich, Germany. Now, we do enrich a lot of the flow information we get. So the GeoIP of the geolocations of IP addresses and hosts is not a typical part of flow data, of the flow data data set. But our collector knows those geolocations, and it will add that information, making the data even more valuable. And lastly, I wanted to show you, how you might detect like a rogue DNS or DHCP server. And so like a new DNS server popping up in your network could be cause for alarm, right? It could be a fake DNS server that's sending people to malicious sites. It could be just an unsanctioned or unsecured DNS server. It could be creating a risk for your organization. DNS are valuable records. A rogue DHCP server, again, this is something that could bypass all the security in your network. Someone brings in an access point or whatever, plugs it into the network, and now you've got a bunch of unauthorized clients on your network. So you can detect these things pretty quickly by having visibility into what DNS and DHCP servers are on your network. If we go to core services here, I'll take these filters off. I can see all of my DNS servers currently in use, how many requests and responses are going to and coming from each one. So I know that, okay, these top four these top four are valid DNS servers, and this last one is not a valid DNS server. So I could filter on that, and I could go over to the top talkers and see exactly who is at fault. Who are the clients in my network that are trying to use a rogue DNS server? And then where are those clients located, right? If there's a geolocation attached to them, I would know right away. In this case, they're located in Munich. Okay. So if you've got a sprawling network topology, this is going to really help you understand who you need to put a ticket in with or who you need to call. Back on the core services dashboard, we can do the same thing with DHCP servers, right? So here's your list of DHCP servers. Let's look back last 15 hours of traffic here. There we go. So good. We only have one DHCP server in use. That's what we want to see. If there are more than one, you could certainly, or more than whatever number you should have, you can actually get a Slack message about that, or an email alert, or a ServiceNow ticket. All those connectors are available out of the box. PagerDuty also works. So now we've talked a lot about security. This is a huge risk area for organizations. But of course, what we're providing is also valuable for network operations. And for example, application dependency mapping is something that network operations teams need to understand, right? If you're migrating applications to the cloud or now back from the cloud, which we're seeing now, you need to keep those components together and keep them communicating. So it's similar to what you would do with a microsegmentation exercise, but with a NetOps lens, right? And so again, if we're back on our dashboards, you could go ahead and let's see here. This is a application dependency mapping. I could choose like an application. I'll choose, let's say, yeah, I think SSH is a good one. We'll choose SSH, and I could see exactly which clients and which hosts are using SSH and how they're using it, and what services are flowing, right? So I can see there's many different GitHub components that are being utilized. I can see who's using them, how they're using them, what port it's flowing over, and then what are the hosts that are supporting those applications. So, and I can also have predefined filters for all of this. So I don't have to type in or select anything. I could just literally load a filter that I've saved, and I've got dashboards. These dashboards can auto refresh as well, so they're perfectly suited for a knock display. It just makes exploring the data very, very easy and understanding the data very easy. Bandwidth and capacity planning. This is a huge one. Obviously, this is, I would say, the number one network operations use case for flow data. As an example, if we were to look at this from a network devices view, I'm looking at my network utilization across the last 2 days. You can see that on top right. And I want to address a capacity issue that I see with an edge router, right? So I'll go ahead and pick that router from my list here. Actually, let's switch to a different device. Yeah, we'll stick with this edge router, that's fine. And I can see a breakdown of utilization by port. Okay. So I can see that Ethernet 0 is driving the majority of my traffic. Now, granted, it's not a lot of traffic, but in this demo, this is a large amount of traffic compared to the other ports in use. Okay. So I'll just choose Ethernet 0 from this list here. And then I can go ahead and select a traffic spike I'm interested in learning more about. So I'll highlight that from a time perspective. We'll go over to the Top Talkers dashboard. And then this is the clients and the servers, and also the sources and destination hosts that are driving this traffic. So I know who's responsible. If I pivot over to the applications view, well, we can go to the services view. We can go to services and see the utilization during this time broken down by layer 4 port. Unsurprisingly, the top port is a 443, right, for TLS. We also see a lot of Zoom traffic. Okay. If I switch to an apps view, this is going to be kind of like, think of it as layer 7. So these are the applications that are consuming the traffic during this traffic spike. So this host here, .133, is he's driving most of the traffic. And I can see if I filter on him that he's using Apple services mostly. So if I filter on Apple services, I now see the servers that are supporting Apple services. So if this were an internal application, I would know exactly who's responsible for the traffic spike, how often it happens, how large it is. And so I can engineer the traffic out, or I can plan for application capacity going forward. And of course, because flow data is so efficient, I've got a long history I can look back at to make an intelligent decision about that. I would also, of course, through the anomaly detection capabilities, be kept abreast if this changes drastically. So I could have been proactively alerted through like a Slack message, for instance, that there is a spike here, and it's because of, in this case, Apple services. Okay. So again, helping you to intelligently size your application capacity and your networks. Application and availability and performance is a big one for network operations. If we go back to the dashboards here and we look at things again from a flows perspective, I'll take these filters off. By the way, you can filter on anything. If you open up a filter to edit in the edit mode, you can filter on any piece of metadata that we captured, which is over 7,000 pieces of metadata now. And you've got Boolean logic to really focus and narrow down what you're looking for if you wanted to go like an advanced route. Okay. But so we'll look at everything from an applications perspective. Cool. And what we can do is, let's say I'm getting complaints that users are not able to access a particular application. Let's just say that they're not able to establish a remote session through SSH. Okay, again, this can be any service. I can then, let's look back at the last 15 hours of traffic. Okay. And I could then ask the system to show me wherever the TCP session could not be established. Okay, so I want to confirm that this user is actually having a network issue and see if anyone else is having that problem as well. So with just a couple clicks, I can see all of the hosts in my network that are having the most amount of issues connecting to establishing a TCP session with SSH. And I even know the SSH servers that are not accessible. Okay. So now if I wanted, I could flip this around and I could investigate a security incident. So maybe I would want to see in that case where the session could be established, right? And I can see that I've got some outside IP addresses that are establishing a connection with my outward facing SSH server. Maybe I have an SSH server that's facing out to the internet, that's open to the internet, but obviously it shouldn't be, right? I would know that very, very quickly by looking at this data here. So both network operations, security operations would benefit from this visibility here. So that concludes the live demo portion, and I wanted just to summarize the benefits that ElastiFlow has from the legacy or run-of-the-mill solutions, right? Obviously, our solution's flow-based, and we feel that's going to give you the richest data set because of how it scales and how efficient flow data is compared to full packets. Now, a lot of solutions out there will summarize information, meaning they will discard information elements, flow fields, pieces of metadata, even flow records themselves, in an attempt to keep the data set as small as possible, because the data platforms sometimes have trouble keeping up, okay? We support many different data platforms. The one I'm showing you today is based on Elasticsearch. And so Elasticsearch is extremely fast, as you saw in the demonstration. And so with it, you can afford to have high resolution data and enrichment where nothing is discarded. You need all those data points to make the most accurate bandwidth predictions and have the most accurate anomaly detection and visibility, right? You want to see everything. Now, with our integration with Elasticsearch, you have a high level of explorability. Clicking around is easy, filtering is easy, dashboarding, alerts, all that is very accessible. All the data is available via API. If you want to pull the data out using another system, you can. You own the data 100%. And the dashboards all come out of the box. So when you're looking at solutions, make sure that you can look at the data however you want, because the vendors themselves don't necessarily know all the ways that you might want to use the data, because as you can see, flow data is very flexible. So you want to be able to make changes and change how you see the data yourself. Our offering, we feel, it gives you an immense amount of agility and control. So the solution leverages open data platforms. So that means your data isn't locked up in a proprietary system. Again, like I mentioned, it's available via API. This is a solution that you can host yourself. It's simple to host yourself. So you don't necessarily need to have a SaaS solution to have great visibility and a great user experience. The dashboarding is very modern, as you saw. So you maintain 100% control of your information, and you can use it however you want. You're not going to be locked into anything, and so it really gives you a lot of freedom to handle your information your way and gain some great insights into security operations and network operations with east-west visibility. So coming away with this from this, I wanted to provide some recommendations, right? And that's to assume that your perimeter is porous. Assume that your perimeter is not going to work, because it's not going to tell you when it's not working. If it could do that, then it would be working, right? And assume that waiting for endpoints to alert you of issues is going to be too late. Endpoints are a bad option to rely on that, because it requires the endpoints, first of all, to be functioning and to be present. It requires the endpoint to be installed, which can't be installed everywhere. They're host-based, right? And why wait till an attack hits an endpoint when you could detect it at the very fabric of the network using flow data? You want to shrink your broadcast domains physically or logically, and you do this with dependency mapping and microsegmentation, right? You want to limit the blast radius. You don't want an email that an executive assistant, for instance, might open, or a call center rep might open, and have that email, that malicious content, affect the production data center, right? Now, production data is now encrypted. When if you had that small broadcast domain for just the call center, then it would be contained within the call center. And east-west visibility would help you to design that broadcast domain. And then lastly, of course, you want to remove all blind spots as soon as possible. And we feel that the most efficient way to do that is with flow and flow logs. And so that is the end of our presentation. So let's go ahead and do some Q&A. And Carla, are you going to be, I can actually read the questions, or do you want to do that?
I can do that. That's fine.
Okay.
We already got one question. Please feel free to add in more questions as we go through this list. I'm going to start with question 1. How does enriched flow data from ElastiFlow help reduce the time to detect and respond MTTR compared to packet-based or endpoint solutions?
Yep, great question. So the ElastiFlow solution, the data is again, lives in an open data platform. It's very fast, and it allows collaboration among teams across the globe. So when you're tackling a problem, typically people don't work by themselves, right? And so you need to be able to have multiple people accessing the data at the same time, asking questions and sharing information. And that's what our solution offers, is that fast collaboration to drive down the mean time to respond. Additionally, looking at flow data again, much smaller amount of data has to be sifted through. So any alerts through like anomaly detection and things like that are going to happen much faster.
Thank you, OJ. So we still have another question. I can see that John typed something in the chat. What went into the security zone violation dashboard? Were the security zones source and destination user defined metadata for IP CIDR blocks? What was the filter for security zone violation filtering on?
Got it. Yeah. So the security zone validation. So that filter actually did not use any hard-coded CIDR blocks or IP ranges or subnets or anything like that. It's literally a query that is looking for traffic that's leaving one security zone and going to a different security zone. So it'll never show traffic within the same security zone. And John, actually, we've worked together a little bit on ElastiFlow, so I can share that. Excuse me, I can share that query with you as well, so you can see how we did it.
Awesome, thank you, OJ. So the next question is, for organizations implementing microsegmentation, what best practices do you recommend to validate whether segmentation policies are actually effective using ElastiFlow?
Yeah, I would say what you would want to do is use our user-defined enrichment. So you can actually say, hey, this group of hosts, this group of IPs, these networks are part of this network segment, this microsegment, right? So you define those microsegments in ElastiFlow. And then once you've done that, then you could use something like that security zone violation dashboard that I showed you, where it would show you where you have traffic exiting one segment and going to another. And then once you've got that, then you could easily convert that essentially to an alert so that you could be proactive.
That's awesome. Thank you, OJ. Any more questions? I'm gonna go ahead and answer the last one if anyone doesn't have any additional questions. That would be it. We'll just move to the next slide. What advice would you give to teams struggling with hybrid environments where cloud and on-prem visibility is fragmented? How can ElastiFlow provide a unified view?
Got it. Great question. Yeah. So typically, there's a lot of pivot fatigue that people experience because they need to use a separate dashboard or separate console or even a separate skill set to have visibility in different networks. You've got 4 different network technologies, or 4 different network vendors, 4 different clouds, whatever. You've got 4 different places to look for traffic. It's difficult to stitch everything together. And with flow data, with our collector, we don't care where the data is coming from. If it's coming from a network device, any vendor, if it's coming from public cloud, we'll ingest it and normalize it into one dashboard or in one system. So you can query one system instead of 4. And that's how we'd help.
That's awesome. Thank you, OJ. If there are no more questions, or if any other questions come up later, you can always reach out to OJ at his email here, oj@elastiflow.com. You can also reach out to our sales team with sales, whose email is sales@elastiflow.com. And oh, it looks like John has another question. We can take that, of course. What are some of the challenges for application ID at the flow collector level? Does collecting flow form, say, an NBAR capable device improve things much? Is there any industry-wide efforts to standardize app ID?
Yeah, that's awesome. So NBAR is very signature focused. It's actually a great technology from Cisco for application identification. So it's something that definitely there's a lot of value with. And the way we're ingesting that data is we're normalizing it along with all the other application identification that we're doing, that Palo Alto's doing, that Fortinet's doing. So we can unify it all into one view. But yeah, I definitely think it's a great technology, and if you have it, you should enable it because we'll support it. And as far as standardizing application identification, I don't think there's any. I'm not aware of any industry-wide efforts to do that. But I do know that we are standardizing. We've standardized how it's presented, so all the different vendors can identify apps however they want, and then we'll provide that single unified view into that data with our dashboards.
Awesome, thank you. Oh, looks like Fabian also had something in the chat. Currently, to enrich data in ElastiFlow before sending it to Elasticsearch, is it possible to do it based on IP or interfaces? Is it possible to search for a specific field and add an additional field in the metadata?
Correct. Yes. So right now the flow records can be tagged with any data that you want to add business context, but that will be based on the IP addresses, IP ranges, things like that, or interfaces. So you can tag an interface with like the name of a carrier, for instance, so you know that that interface is for that carrier or coming from that carrier. It is currently not possible to so yeah, and actually you can tag really data. You can add data also based on any other field, and you would do that through like an enrichment pipeline with Logstash. But yeah, out of the box, like with our collector, it's going to be based on IPs and interfaces. But yeah, if you want to go more advanced, you can use Logstash enrichment pipeline.
Awesome, thank you, OJ. Looks like John also has another question. Is enrichment via MAC addressed far away? Addresses far away, sorry.
Yep. So I know we're revamping and improving our enrichment system so that we can handle thousands of enrichment fields, enrichment tags. And And so enriching based on MAC addresses might be an option during that time, because it's going to scale a lot further than it scales now. But you still get access, you can still enrich based on hundreds of tags. But I think when we're scaling like to thousands, it could be, there's some improvement there. If you want to enrich via MAC addresses, I think I'd go the Logstash route for the time being, until we have that faster enrichment solution I was mentioning.
Awesome. I think I'll give it like a 10-second pause in case any other questions come up before we move on to the next slide. Okay. So
So
thank you for attending.
Oh, sorry, go ahead, Carla.
No, I was just going to say thank you everyone for attending. And I just wanted to share a reminder that OJ will be attending Cisco Live. And it will be really nice for you to stop by our booth if you are planning to go there. And OJ, back to you.
Yeah. So we do offer a 30-day trial of our product. We actually have excuse me, an OVA or a virtual appliance that you can download and boot up, and start seeing all the data that we showed you today. It's very, very simple to get going. So please contact us and we can help you get started. Thank you for joining.